So verbally, I'm going to give you the answer to the first question. Inverses swap domain and range. That's what they do. Moving on to number 2, use the table to find. Okay, so since I know that inverses swap x and y, I'm just going to go right off to the side and I'm going to make another table. That's what I'm going to do. You don't have to do that, but it'll make more sense if you do. Well, what do I need? I need 5 rows in my table. So this one would be x and its inverse, f of x. And we're just going to swap things around. That's all we're going to do. Okay, now find f of 2. So when x is 2, the f of 2 value is -4. We should be able to do that. The domain for the inverse. Okay, so the domain for the inverse is going to be all of these y values, or since I did it, all of these x values from lowest to highest. -4, -3, 2, and 5. The range for the inverse, well, that would be these values right here. And they're actually already in increasing order. That's kind of cool. 2, 5, 9, 12. All right. The main reason I wrote the table was for this. What is the y value of the inverse when x is 2 and it's 5? You could also look at it like this because they swap things. I don't know if you'll figure that out or not. Just make another table. All right, number 4, if f of x is the square root of 3x minus 1, find the domain and range of f to the -1 of x without actually finding the inverse. So it's not actually that bad to do. It's really not. I know that for the square root of something, the stuff inside is greater than or equal to 0, okay? So 3x minus 1 is greater than or equal to 0. So 3x is greater than or equal to 1, which means that x is greater than or equal to 1/3. So when I talk about my domain, I'm simply 1/3 to infinity. Now, when I go over here and I talk about my inverse, since I have the domain, I have the inverse's range. The inverse's range would be 1/3 to infinity. Now, the range of a square root function is going to be kind of hard for y'all to do because as a class, you guys you didn't do well on these things in the past. And we haven't officially talked about it in this unit, but a rough graph of this thing, and I could verify it with Desmos real quick. A rough graph would have this thing shifted just a little bit to the right because the domain was 1/3 to infinity, so it'd be about right here. And then it would look like that. So its range would be 0 to infinity. I need a bracket on that 0. Now, I know you probably don't believe me. You think I'm just making stuff up in my head. That was a square root of 3x minus 1, right? I promise you I'm not. I drew you a very good graph. Looky right there. There's that 1/3 value. The y value is 0, and it does exist, and it rises forever to infinity. So I told you, I didn't lie to you. But since that's the range of the original function, it's going to become the domain of the inverse because inverses swap domain and range. That's what they do. So I've given you 3 of 5 problems so far. I'm not giving you that one, apparently neither one of those two. So this will be 4 of 9 problems I've given you. Graph f of x equals 4x plus 8 to the 1/2 plus 3. We did this back in August. I'm going to view this first off as what she is. She is the square root of 4x plus 8 and then plus 3. I can pull a 4 from both terms in the middle. You notice I'm putting that understand 2 there. I don't do that for me. I do that for you. Square root of 4 is 2, so this becomes 2 square roots of x plus 2 plus 3. Now, you may or may not remember your forms. I'm betting you don't. But it's a lineup process. A is our initial slope. Our initial slope is 2. I'm not going to write that down. The plus 2 means left 2, and the plus 3 means up 3. Now, the mother function is y equals the square root of x. So smallest thing you take the square root of is 0 is 0. The next smallest thing you can take the square root of is 1. The next smallest thing you can take the square root of is 4. This is mama, okay? The kid's going to look like mama. So when I actually draw this kid, I'm going to go left 2. Do that in a new color for you. Could have swore I picked red. Left 2 and up 3. And that's where I'm going to start. Now, this is my slope, at least my initial slope. Instead of rising 1 and running 1, I'm going to rise 2 and run 1. And I'm going to get a much steeper arm. Now, this is the graph, okay? And what I'm asking you to do is if you can derive the equation of its inverse. And I bet you can. What I mean by that is we're going to label some points and we're going to swap them, okay? So this point right here was -2, 3. And I went up 2 and over 1, so that got me to -1, 5. Let's talk about the inverse here. Inverses swap x and y. Instead of being -2, 3, I would be 3, -2. Right there. And instead of being -1, 5, I would be 5, -1. I'd be right there. It looks something like that. It wouldn't be an arm anymore. It looks something like that. Remember, inverses are opposite, and the opposite of a square root is going to be a square. If you paid attention in class the other day, you learned that we actually throw away half the graph of a square to write its inverse. That's how we do it. So let's take a look at this here. It looks to me, I'd have a hard time with the initial slope here because it's not 1. But anyways, this is in the form of y equals a times x minus h quantity squared plus k. It is a parabola with a domain restriction in that the domain is 3 to infinity. See how I looked at that point right there where this one stopped? I looked at the old range, 3 to infinity. So the domain is 3 to infinity. That's why it's only drawing half of it. Now, I've got my vertex here at 3, -2. I can plug those in. Y equals a times x minus 3 quantity squared minus 2. And if I want the true a value, I can plug in the other point. And the other point was at 5, -1. So 5 equals a times -1 minus 3 quantity squared plus 2. Sorry, minus 2. A -1 take away 3 is a -4. A -4 squared is 16. There are 16 a's. I'm going to add 2 to 5 and get 7. So my a value is 7/16. So here's my actual equation. Y equals 7/16 of, I don't know why I did a square root, I'm tired, of x minus 3 quantity squared minus 2. Now, there's a reason I did number 9. It was kind of a rough problem. All right, next up I got 12, 14, 15 selected. Draw a rough graph, then write the inverse of the given function if the function is not one-to-one, restrict its domain so that you can invert the function. So before I actually think about what this thing looks like, it says PS, graph the equations using your TID4 Desmos, determine if they're one-to-one if you never bothered to memorize some other functions. If I'm looking at number 12, I pull the 2, and that leaves me with x minus 4 and then plus 4. Left 4, up 4. Puts me about right there, and it is an arm. The arm will pass both vertical line test and horizontal line test. It passes HLT and VLT. And it already has a domain restriction. Its domain is going to be -4 to infinity. And its range happens to be 4 to infinity. Now let's go through the process of writing an inverse. There are 3 steps. The first step is to swap x and y. We're literally going to get this f out of here. X equals the square root of 2y minus 8 plus 4. We're going to subtract 4. X minus 4 is the square root of 2y minus 8. The opposite of square rooting is squaring. And we're going to go ahead and figure this out. This is x squared minus 8x plus 16. And it would be equal to 2y minus 8. Add 8 to both sides. X squared minus 8x plus 24 is 2y. And then divide everything by 2. So y is going to be x squared. Let's not, because that would make it look a little uglier. That's not a big deal. X squared over 2 is a half of x squared minus 4x, and then plus 12. Now, the third step in writing an inverse was notation. F to the negative 1 of x. Remember, your three rules were 1, swap x and y. 2, solve for y. 3, notation. Ta-da! All right, now on to 14. And I'll probably get caught by the bell or something here in just a second. So maybe there might be 2 videos to this homework. Now, when I look at 14, I'm just really concerned about mama, to be quite honest with you. This is a cubic root function, right? This is x to the 1/3. Looks something like this. All cubic root functions are 1-to-1. They all pass horizontal and vertical line tests, so they're all 1-to-1. So let's just get that g out of there. We're doing the swap x and y step. The algebra on this one, who knows? It ain't going to be too pretty. That x should have become a y. I got ahead of myself. And then plus 4. Baby steps first. Subtract 4. X minus 4 is 3 cubic roots of 2y minus 5. Write small, by the way. Next move, divide by 3. X minus 4 over 3 is the cubic root of 2y minus 5. Next move, counteract cubic rooting by cubing. And the only thing I would cube on this one, but what do I know? It's not like I'm a math teacher or anything, is the bottom piece. Because nobody wants to write out x minus 4 3 times and do that work. Anywho, that's equal to 2y minus 5. Next easy move, add 5. X minus 4 cubed over 27 plus 5 is twice y. Next move, divide by 2. And by the way, division happens in the denominator. Finally, x minus 4 cubed over 54 plus 5/2 is y. Easy peasy lemon squeezy, right? I'm sure that was so easy. Sure it was. Okay, so I think I got enough time to do number 15. Let's take a look at that on Desmos, because I haven't, x to the 4th isn't one of your required memorizations. It's really not. So we got 1/2, and it's going to look like a parabola, by the way. It is. I swear it is. It's going to look like a parabola. It's in vertex form. It's going to look like a U. It's going to be a little flatter than normal. I doubt you'd even tell that, to be honest with you, that it is. But it's just going to be a flatter parabola. And then minus 2. Well, I guess you can see it on Desmos. See how it's flat? But anyways, the idea on this is it fails horizontal line test. Horizontal line hits that thing 2 times. And we can't have that. So we're going to throw away this whole left-hand side. Our domain restriction is going to be -3 to infinity. That's what we're going to say. Our domain is -3 to infinity. And we have to say that our domain is negative to infinity. It says if the function is 1-to-1, restrict the domain so that you can do it. So your domain restriction would say -3 to infinity. Eventually kids catch on that it's just opposite of whatever's in the parentheses. That's what it is. All right, let's get the f out of that f of x, because f of x is fancy for y, and we're swapping x and y. That x becomes a y. We have a 4th power, minus 2. We're going to add 2 to both sides. X plus 2 is 1/2 of y plus 3, all to the 4th. The opposite of multiplying by a half is multiplying both sides by a 2. Gone. That's 2x plus 4 equals y plus 3 to the 4th power. The opposite of the 4th power is the 1/4 power. And I'll be honest with you, as much as I love exponents, a radical just looks better to me. I'm a radical guy, I am. I like the way the fourth root looks, and you should too. You don't have to. Everybody has their own preferences. And then we're just going to subtract 3 and be done with this thing. Now, if you remember step 3, which is notation, since y is all by itself, we replace that with the inverse of f of x, written f to the negative first of x. I don't think I've got enough time to do anymore. No, I'll have to do this in a separate video. Anyways, there's the first couple. Hope you enjoyed. I'll do another video at some point in time today or tomorrow morning, probably tomorrow morning.